In this video lecture, we will talk about bile secretion by liver and gallbladder emptying, right? So this is the diagram that shows the liver and the gallbladder, right? And you have a duodenum here. We'll talk about it. So we know that bile is secreted by liver and is stored in gallbladder, right? So in this video lecture, we will talk more about what happens to bile when it is stored in gallbladder and its secretion by liver. Right, so bile is secreted, right, or formed or produced or formed by liver, right, and these are and bile is secreted by hepatic cells, right, hepatocytes, right, and secreted by hepatocytes, which are liver cells, right. Now bile has very important function to play, right. Bile, first of all, bile contains water, it contains bile salts, it contains bilirubin, right, then it contains cholesterol, contains lecithin, then you have electrolytes like sodium ions, right, chloride ions, all this, right, all these are in your bile, right. You have fatty acids also, bicarbonate ions, right? You have bicarbonate ions, right, you have fatty acids, right. Each of these has a role to play in bile, right. So first, very important function of bile component, bile salts. It has a very important function to play, right. So we'll be looking at bile salts, or we call it as bile acids. Let's call it as bile acids. Bile acids help in the digestion of fats, right, and the absorption of digested fat products. We know that digested fat products are monoglycerides and fatty acids, right. So it helps in the absorption of fatty acids, right, and its main important function is that it helps in the digestion of fats. It helps in the emulsification of fats. Emulsification of fats is when bigger fat particles or fat globules are broken down into smaller fat particles so that they can be acted upon by enzyme lipases, right. And why it is required to break bigger fat particles into smaller ones? Because if you look at this is a bigger fat particle, right. It would be broken down into smaller fat particles, right, and these are your enzyme lipases. These enzyme lipases would not be able to work effectively on bigger fat globules or bigger fat particles, right. But once the bigger fat particles are broken down into smaller fat particles with the help of bile acids, the surface area will increase. Now these lipase enzymes have more area to work on, right. So lipases work on these or digest these small fat particles, right. Once it is digested, it is changed into fatty acids and monoglycerides, and these digested fat products would be absorbed, and this absorption is also assisted by your bile acids or bile salts, right. Now emulsification of fats and fat digestion we would be covering in a different lecture. Here I'm just want to tell you the function of bile salts, which is one of the component of bile, right, bile salts or bile acids. So this is most important function of bile salts or your bile acid, right. And the most important function of your bile is that it helps in it helps in the excretion of waste products of blood. Right? Waste products of blood are your bilirubin, and then you have bilirubin. We know bilirubin is formed from hemoglobin, right? And excess of cholesterol, right? So bile salts, first let's take it down. It helps in the emulsification of fats, which we just discussed. Helps in the emulsification of fats and absorption of digested products, right? Digested products are fatty acids and monoglycerides, right? And its second important function, it helps, this bile acids helps in the excretion of waste products, in blood, right, which is your bilirubin, right? Bilirubin, which is an olive green colored liquid, right, or it's a yellowish brown colored liquid, right? And this bilirubin is formed from hemoglobin. When your red blood cells matures, right, when they come to the end of their life, they dissociate, right? We know that hemoglobin consists of a porphyrin ring, where it has iron at the center, and it is surrounded by 4 pyrrole rings, right? Now when the red blood cells dies, what happens is this hemoglobin breaks into heme and globin, right? And this heme is a ring. Heme ring, when breaks, the iron is absorbed in the blood, right? And the pyrrole rings, the straight chain pyrrole rings, would be changed into your bilirubin, right? The straight chain, or the pyrrole, or the ring of, or the chain of pyrrole rings would first change into biliverdin, which is reduced further to bilirubin, right? This is how this is formed, right? This is taken in a different lecture on hemoglobin. It's just, I'm trying to let you know what exactly it is. So it helps in the excretion of waste products in blood, which is your bilirubin, and is formed from red blood cells when they reach their maturity, right? And it also helps in the excretion of excess of cholesterol, right? So I repeat, bile acids in bile helps, right, for the excretion of waste products from blood, which is bilirubin, right, which is an end product of hemoglobin destruction, as we've discussed, and your excess of cholesterol. It also helps in the excretion of excess of cholesterol, right? We know that cholesterol in right amount is good, but when it's excess, it's not good, right? So it helps in the excretion of excess of cholesterol. Now let's quickly look into the excretion of bile, the anatomy of excretion of bile from liver and its flow into duodenum, right? The diagram that you see, this is your liver, right, that secretes your bile, right, from hepatocytes. Hepatocytes, which are liver cells, will secrete bile, right, and they secrete bile in small canaliculi, which is between hepatic cells, right? Canaliculi is used for small canals, right? If this is your, these are your, say, hepatic cells, right? So these are canaliculi. So bile is secreted between the hepatic cells in these canaliculi, right? Now these canaliculi will further join small ducts, right? And the small ducts will finally join right hepatic duct and left hepatic duct, right? Now this right hepatic duct and left hepatic duct will form a common bile duct, right? Now you have an organ, gallbladder here. This gallbladder has a cystic duct. Now this common hepatic duct, right, will join, when move further, it will join this cystic duct to form the common bile duct, right? This is important. You have two lobes in your liver, the right lobe and the left lobe, right? So duct in your right lobe is your right hepatic duct, duct in your left lobe is your left hepatic duct, right? So this is your right hepatic duct, your left hepatic duct, right? These both join, right, to form your common hepatic duct. This is your common hepatic duct, right? And this is your right hepatic duct. Say this is a right hepatic duct and this is your left hepatic duct, right? Or this is your right and left hepatic duct, and this is your common bile duct, right? Because what is flowing here in these ducts is bile, right? And what is flowing from your gallbladder, which stores bile, is your bile. So in both the ducts you have bile. So when these ducts join, they form common bile duct, right? Because both carries bile, so it's a common bile duct, right? So this is your common bile duct, which will later be joined by cystic duct, right? This is a cystic duct which is coming from gallbladder, right? This is your left hepatic duct, this is your right hepatic duct, this is your common bile duct, this is your common hepatic duct, right? This is cystic duct and this is your common bile duct. Remember this diagram, right? Now this common bile duct will finally join the sphincter of Oddi, right? It joins here the duodenum into the sphincter. Here this is your sphincter of Oddi, and this is your pancreatic duct, which is coming from pancreas, and it contains pancreatic juice, right? So this is the labeling, right? Now we have just talked about the flow of bile. Now when bile will flow from left and common hepatic duct, it will join a common hepatic duct, right? Now this movement of bile from your hepatic duct from your common bile duct, right, into your duodenum, because the bile from common bile duct will empty into your duodenum, right? And this movement of bile from common bile duct to duodenum is regulated by sphincter of Oddi. Only when sphincter of Oddi will relax, then only it will open the gateway for bile into the duodenum, right? So just understand this. Now just understand one thing. We said that gallbladder stores bile. How come it stores bile? Because it is produced by liver. If this sphincter of Oddi is closed, if suppose there is no food, the sphincter of Oddi will relax only in response to food in the duodenum. When food reaches in the duodenum, in the upper intestine, in the upper smaller intestine, then only this sphincter of Oddi will relax to allow bile to flow in to digest food inside the duodenum, mainly your fats, right? Because we have discussed here that bile, right, is used for bile acids in your bile acids or bile salts in your bile will help in the digestion of fats. So when fats reach fatty food, mainly reach in duodenum, the sphincter of Oddi will relax and bile will flow inside your duodenum and will start digesting your fats, right, by their emulsifying action, right. So till this point it is clear. Now suppose, since this liver, the hepatic cells are continuously forming bile, right, since these cells are continuously forming bile, they will keep releasing bile in the bile ducts, right. Now suppose there is no food in the duodenum, sphincter of Oddi is closed, right. So when bile is flowing inside, right, and the sphincter of Oddi is closed, it will not allow its entry into duodenum. So this bile will start backing up. When this gate is not opened, it will start backing up, right, and through this cystic duct it will start moving inside the gallbladder, right. This is how it will get stored in gallbladder when sphincter of Oddi is not opened, right, or not relaxed. When sphincter of Oddi relaxes, gallbladder will start emptying bile into the duodenum. We'll just go through in a minute the emptying of gallbladder, right, because it's part of this lecture, right. So I repeat once again, when sphincter of Oddi is not relaxed, right, the bile will start backing up, right, it will move in the reverse direction and through cystic duct it will move in the gallbladder, so it will get stored in the gallbladder. When fatty food reach the duodenum, the upper intestinal region, the gallbladder will start emptying bile into the duodenum, right. So now it is clear how it stores bile. When the sphincter of Oddi is not relaxed, bile will get stored in your gallbladder, right. So when sphincter of Oddi is not relaxed, when we say it is not relaxed, that means no food in duodenum, right, no food in duodenum. So bile will back up and get stored in gallbladder, right, and gallbladder can store around 30 to 60 ml of bile, which is a day's secretion, right. So it gets stored in gallbladder and will empty in response to food, right, or you may call it as fatty food in duodenum, right. I hope this is clear, right. Right, now liver bile secretion, liver secretes around 600 to 1000 ml of bile in a day, right, just remember that. And its pH is 7.6 to 8.6 because it contains bicarbonate ions, right, which are basic. So the pH of bile is, right, pH of bile is 7.6 to 8.6, which is slightly towards alkaline side, right, and its secretion is 600 to 1000 ml, right, 600 to 1000 ml in a day, right. Now let's look at the other part of secretion. There is a hormone called hormone secretin, right. In response to hormone secretin, the liver will start secreting, right, it in the second stage. In response to the secretin hormone, a second portion of liver secretion is added to the initial bile, right. The initial bile, which is in these bile ducts, right, to this bile, a second secretion would be added from the liver in response to hormone secretin, and that secretion mainly contains your bicarbonate ions, right, sodium and your bicarbonate ions, right? So it is alkaline. So a second secretion from liver is added to bile in response to hormone secretin, right? And this secretion mainly contains your sodium ions and bicarbonate ions, right? Now let's talk little about now gallbladder storage, right? Storage of bile in gallbladder. Gallbladder stores and concentrates bile, right? Most important thing is gallbladder it stores and concentrates bile, right? Important thing is it also concentrates bile, right? When bile is stored in gallbladder, it will absorb water and electrolytes, right? Thereby concentrating the other components of bile, which is your bile salts, bilirubin, cholesterol, lecithin, right? So when your gallbladder is stored in, your bile is stored in gallbladder, it will, the mucosal wall of your gallbladder will start absorbing water, right, and ions, right? Active ions will move via active transport in your gallbladder wall, right? By active transport we mean that ATP energy is required, right? So when it absorbs water and electrolytes, that means the remaining part will become concentrate, right? So this is your concentration of bile in gallbladder, right? Via absorption by the mucosa wall of your duodenum, right? And this is stimulated, right? We'll just look at the other part, which is stimulated by cholecystokinin, the gallbladder emptying. We'll just talk about it in a while, right? So bile is stored and concentrated by your gallbladder, and gallbladder can hold around 30 to 60 ml of your bile, right? And it concentrates your bile 5 to 20 fold, right? So gallbladder concentrates your bile 5-fold to 20-fold, right? And it concentrates bile by the mucosa wall will absorb water and electrolytes, right? Thereby concentrating the remaining bile, right? This is important, right? Now let's look quickly into the gallbladder emptying, right? Like I explained in the beginning, that when you have food, right, fatty food in the duodenum, the bile will start emptying from the gallbladder into the duodenum, right? And this emptying is effective only when the sphincter of Oddi will relax, because when sphincter of Oddi will relax, then only the gateway of bile will open towards the duodenum, right? And now let's quickly look at how this emptying is done. When your bile is in gallbladder, the wall of the gallbladder will rhythmically contract, right? There are rhythmic contractions of your gallbladder wall, right? Right, so with rhythmic contractions, the gallbladder starts emptying, right, when digestion begins in your upper GI tract, or when food is present in the duodenum through rhythmic contractions, rhythmic contractions in the wall of the gallbladder, it will start emptying bile into the duodenum, right? And this emptying is effective only when the sphincter of Oddi will relax, right? And this is stimulated by a hormone called cholecystokinin, right, which stimulates gallbladder emptying, right? So gallbladder emptying, let me just write it over here. Gallbladder emptying right? Gallbladder is emptied by rhythmic contractions of gallbladder wall. Just reusing the short term, gallbladder wall, right? And it is stimulated by hormone cholecystokinin, right? It is also abbreviated as CCK, right? This is stimulated by hormone CCK, and it is also, this rhythmic contraction is also to some extent stimulated by acetylcholine, right? Acetylcholine secreted by vagus nerve, which we know from our previous physiology and anatomy knowledge, right? So it is also stimulated to less strongly by acetylcholine, right? Right. So I hope all this is clear, right? Just understand that the bile, which is secreted by hepatocytes continuously, right, flows into common bile duct, right? And from common bile duct, when food is present in the duodenum, in response to the presence of food in duodenum, the sphincter of Oddi will relax, allowing the passage of bile into the duodenum, right, where bile salts in bile will start emulsifying fats, right? That means bile salts, like we discussed, helps in the emulsification of fat, right? Then we discussed that bile acids helps in the excretion of waste products like bilirubin, which is the product of destruction of hemoglobin, right? And excess of cholesterol, right? Then we also discussed about the concentration of bile in your gallbladder. When gallbladder stores bile, it concentrates bile, right, by absorption of water, right, by absorption of water and electrolytes by its wall, right? So the mucosa wall of gallbladder will start absorbing this, right? Then we have gone through the gallbladder emptying, right? So when food reaches here, the sphincter of Oddi will open up, right? It relaxes. Then the wall of the gallbladder will start rhythmic contractions, which is stimulated by CCK, hormone cholecystokinin, and is to lesser extent is also stimulated by acetylcholine, right? So this is it, right? I hope this is clear. Now in the next lecture we will go through the gallstones, right? Formation of gallstones in gallbladder. Thanks.